Lesson 2.1, segment bisectors. We're going to bisect a segment, and we're going to find coordinates of the midpoint of a segment. You could, if you wanted to, actually do this activity where you take a piece of paper, draw a line segment on it, and take and fold it so that the one endpoint rests over top of the other, and label that point at the crease M, and measure from end point to M on one side and then the end point to M on the other. M, you would find out that those two lengths are the same, and that M is called the midpoint. The midpoint of a segment is the point on the segment that divides it into two congruent segments. A segment bisector is a segment, a ray, a line, or a plane that intersects a segment at its midpoint. 2. Bisect a segment means to divide the segment into two congruent segments. So please take note to the two diagrams down below. You have M is the midpoint, boom, because it is showing you two congruencies. Those markings, those tick markings, mean congruent. In the next diagram, it's showing you a line going through that point. That is a bisector. So CD, line CD, would be a bisector. M is the midpoint of AB. Find the length AM and the length MB. M is the midpoint of AB, so AM and MB are both equal to 1/2 the length of AB. So if I'm trying to find AM and MB, it's just 1/2 total length, which is 13. Find segment lengths. P is the midpoint of RS. Find PS and RS. Well, RP equals PS. If RP equals 7, then PS equals 7. And we know that RS is actually twice the length of RP. It takes two of them. So 2 times 7 is 14. So you go ahead and try those two. The first one, you're trying to find the two shorter lengths. E is a midpoint. DE then equals EF, which equals 1/2 the whole length DF. 1/2 of 18 is 9. The second one, you know that MN equals NP, and since MN is 11, NP is 11. And you also know that MP is twice the length of MN, so 2 times 11 is 22. Example 3, we're going to use algebra with our segment lengths. Line L is a segment bisector of the segment AB. Find the value of x. So you know that AM equals MB. Substituting in the expressions for each of those, and solve for x by dividing by 5. So x equals 7. If you know the coordinates of the endpoints of a line segment in a coordinate plane, you can find the coordinates of the midpoint of the segment using the midpoint formula. So here is the midpoint formula, the most important thing you want to definitely highlight. It's that it's the two x coordinates added together divided by 2, and the two y coordinates added together and divided by 2. So using the midpoint formula, let's find the coordinates of the midpoint of AB. First off, let's graph our 2 points so we can confirm that it looks like it could be the midpoint. So I want to there's my A, and B is at 7, 4. Okay, so you just designate an x1, x1, y1, x2, y2, and substitute into the midpoint formula. So I want to draw this segment. And substituting it in, I'm going to add the two x's together, divided by 2, and add the two y's together, divided by 2. So 7 plus 1 is 8, divided by 2 is 4. And 4 plus 2 is 6, divided by 2 is 3. Plotting that point, 4, 3, that would be your M. Next problem, graph -2, 3, 5, -1, and again, x1, y1, x2, y2. Formula is to add the two x coordinates together, divided by 2, and the two y coordinates together, divided by 2. So we get 3 over 2 here, and 2 over 2 here. And you should probably write it in the most simplest form, which really is 3/2 here, and that's 1. So where does that look like it is? 3/2 is 1 1/2. So go about between 1 and 2 and up to 1, and it does look like that's correct. Okay, so you go ahead and do the next two, actually it's the next 3, sorry. Sketching the PQ segment, and then find the coordinates of the midpoint. Okay, looking at the first one, you should have x1, y1, x2, y2. You're going to add the two x's, 2 and 4, divided by 2, and you're going to add the two y's, 5 plus 3, divided by 2. Simplifying, the coordinates for the midpoint would be 3, 4. Graphing, you can see what that graph looks like. The second one, x1, y1, x2, y2, you add the two x coordinates together, 0 plus 4 divided by 2, and add the two y coordinates together, negative 2 plus 0 divided by 2. Simplify, you get 2, negative 1. And in this last one, when you add the x coordinates together, negative 1 plus negative 4 over 2, you get negative 5 over 2, which that doesn't simplify any more than that. And the same with the y coordinates, 2 plus 1 is 3 over 2. So to kind of plot that, it would be negative 2.5, which is between negative 2 and negative 3, and up to 1.5, which is between 1 and 2. Okay, so our concept check says you're given the coordinates of the endpoints of a segment. How do you find the coordinates of the midpoint of the segment? You find the average of the x coordinates and you find the average of the y coordinates. So that formula looks like x1 plus x2 over 2, y1, and it is an ordered pair. So you need to make sure you write it in ordered pair form.